Hey, all you cool cats and kittens. This is Mrs. Holm. Welcome to lesson 2 for the week of May 11th. Today we're going to review a little bit about electrolytes and then learn the differences between strong and weak acids and bases. So we talked about this term dissociation just a little bit earlier in April when we talked about solutions unit. So as a reminder, dissociation is a process where compounds decompose or dissolve into their ions. Okay, so really to dissociate is kind of like dissolving with a charge. So here are two examples. You have this ionic sodium chloride. So an ionic salt is breaking up into a sodium cation and a chlorine anion. Okay, and then here sodium hydroxide, we're looking at this as a base, and it will dissociate into a sodium cation and hydroxide anion. Okay, so the reason this is important, this unit, is that when you dissolve with a charge, okay, or dissociate, now you have charges that are free to move, and that makes these kinds of compounds electrolytes. Okay, so an electrolyte is a compound that can conduct electricity in a solution, okay, because they dissociate solutions. Again, whenever we talk about electrolytes, people say like Gatorade, we have our athletes talking about that, and the answer is absolutely. Okay, Gatorade has salts in it that replace these kind of electrolytes, these sodium and chlorine electrolytes in our body, so our nerves and muscles can conduct electricity. Okay. All right, so for today's lesson, we want to make sure you know the three basic types of electrolytic compounds. Okay, so three types of compounds that you should recognize as being electrolytes. The first one would be salt. Okay, now remember when we're talking about salt, we're not just talking about your salt shaker. Salt is a name for any kind of ionic compound. So any metal bonded to a nonmetal. You're going to know that that can dissociate and become an electrolyte. So the second type would be any acid. Okay, and we recognize acids because their formulas start with hydrogen, at least in all of our examples. And then also bases are electrolytic compounds. And we recognize them because they end in hydroxide, this OH compound. Okay, so ionic salts, acids, and bases. We're going to recognize those as electrolytes because they can dissociate and have these charges that can move in electric currents. So an example of the compound that is not an electrolyte would be anything that's covalent. Okay, any kind of covalent molecule, they do not conduct electricity because they can't dissociate. There's no ions or charges. Only ionic things have ions. So hopefully you remember from earlier this semester or last semester that covalent molecules are only made of nonmetals. Okay, so if you have a chemical formula that's only made of things from the right-hand side of your periodic table, it's covalent and is not an electrolyte. So let's look at some examples, okay? This one on your notes wants you to circle all the compounds that will dissociate into electrolyte solutions. So which of the following are electrolytes? Let's look at this first one, PO3. Actually, let's look at our conditions. There it is. Okay, so we're going to circle as an electrolyte any salt, which means metal nonmetal, any acid, which means a formula that begins with H, and any base, any formula that ends in OH. We are not going to circle anything that's only nonmetals because it's covalent and not an electrolyte. So if we look at this first one, PO3, P and O are both nonmetals, which means that is covalent and is not an electrolyte. We want to pay attention to this element right there for the second one. Gold is a metal and chlorine is a nonmetal, which means this is going to be an ionic salt. So I would say yes, that one is an electrolyte. All right, please pause this. Try the rest on your own. All right, let's check your answers. So I circled everything except for PO3. That's a covalent, only nonmetals. This one is glucose, C6H12O6. Those are all nonmetals. Remember, hydrogen counts as a nonmetal unless it's an acid, okay? CO2, that's a covalent one, okay? So the reason I did choose this one is because it's a base. It ends in hydroxide. Even though both of these are nonmetals, okay, if it has an H in front, it's an acid. So that means it is an electrolyte. This one's a base. It ends in OH. This one starts with an H, so it's an acid, okay? You will definitely have questions just like this on your homework check and end of the week lesson. All right, a couple other examples. This one says, of the 4 main ingredients in Gatorade, which is the electrolyte? Okay, so again, what we're looking for is we're not going to choose anything that's only nonmetals. Okay, so H2O has H in the front, so it's kind of an acid, but no, we're going to say that that one is not an electrolyte. Okay, sugar, only nonmetals. Dextrose, another sugar, only nonmetals. So those 3 we would say are covalents. Citric acid, okay, with that H in front in a special way. We're going to say this one is our electrolyte. So citric acid, that's the electrolyte of those 4. Here, the second question says, which of the following would not be an electrolyte when we dissolve it in a solution? Okay, so which one's not an electrolyte? Again, we're looking for the one that's only made of nonmetals. NaCl, I've got a metal nonmetal. That one is an electrolyte. Potassium hydroxide ends in OH, it's a base. This one's covalent. That one's an acid. Okay, so I'm going to come back and say C is not an electrolyte because it's just covalent. Acids, bases, and ionic salts are electrolytes. Okay, if you're having a hard time with that, make sure you check out the homework tutorial for this lesson. It'll help you do that homework check and get ready for your quiz this week. All right, now let's move on to talking about strong versus weak acids and bases. There we go, I forgot about this. After I introduce you to this really, really cool extra credit opportunity. It is a YouTube video. A lot of you have probably seen something from this guy's YouTube channel. It's the King of Random, okay? The name of the video is Water and Electricity Don't Mix. So he's playing with electrical probes and mixing it in water, okay? It's like an 8-minute long video. It's genuinely interesting video. There are a couple questions to answer, and you get 25% extra credit added to your end of the week quiz score. Okay, so please consider looking at that on Canvas. All right, now strong versus weak acids and bases. So this does not mean dangerous and safe. It's not the same thing, and we'll talk about that. We would say that it's a strong acid or a weak base based on the degree that they dissociate in water. Okay, and that's just saying based on how much comes apart in water. Okay, so a strong acid and base will 100% break apart into its ions in an aqueous solution, a water solution. A weak acid and base only partially breaks apart into ions in a water solution. Okay, 99, 98% of acids and bases are weak acids and bases. There are only depending on acids or bases, 6 to 12 each total strong acids and bases. So look at these examples down here at the bottom, these pictures, okay? You see you've got an acid, let's say it's hydrogen bonded onto chlorine, okay? At the end, we see 100% of those are broken apart. They're not stuck together anymore. So this would be considered a strong acid. It's complete dissociation. Over here, we see that before and after, most of them are still bonded together. Only one of them broke apart. So this would still be an acid, but it would be a weak acid, okay? Looking at this example, which one is the strong or the weak? Again, we'd say the one on the left is the strong because you have complete dissociation, meaning there are many different ions here. Over here, it's weak dissociation because there are only a couple that came apart, right? Which also means that this one here on the left would be the stronger electrolyte. There's more charges that can move to conduct electricity. All right, so in this example, it's hard to tell. So it says in the instructions, both lights are on. Which one is the stronger acid? Okay, so the light bulb on the left, we would say is bright. It's brightly lit or brightly illuminated. One on the right, we use the word dim or dimly lit. Okay, so which one's the stronger acid? Well, remember a strong acid has complete 100%, so there's many ions. Okay, if there's more ions, there's more stuff to conduct electricity. So this one, that's bright, is going to be the stronger acid. Okay. The dimmer one, it is conducting electricity. It's just a poorer electrolyte. Okay. Sometimes people confuse the concepts of concentration and strength. Okay. So when we're talking about concentration, we're talking about safe or dangerous. Is that a lemon and you're fine? Or is that, hydrochloric acid and you're about to die? okay? So concentration, that's when we're saying right here, it's not a very concentrated acid, so the pH is 5. Or it's a very concentrated acid and it's dangerous. When we're talking about strength, we're just saying, does it completely come apart or does it a little bit come apart, okay? Working with concentrated strong acids is very dangerous. So a concentrated strong acid or dangerous acids would be anything that's 0 to 2 on the pH scale. Similarly, working with concentrated strong bases is very dangerous. Last year, and I had pictures, but I deleted them because I was mortified by them. I burned off a fingernail with a strong base, with sodium hydroxide. I was not wearing gloves. I was getting ready for our acid-base lab. I was going too fast, and I felt a little bit of solution on my finger, on my right hand middle finger, and I went to go wash it off, and I felt it super slippery, and I went, great, I definitely just got a base on my finger. And within 24 hours, I had 7 layers of skin peel off of my finger. It got infected, my nail died, I went to a doctor, they told me I was an idiot for not wearing gloves. I said, I know, my husband's already yelled at me. They told me they didn't think my fingernail would ever grow back. And it did, but I swear it did not grow back until October. So it was 6 months until it grew back. So a concentrated strong acid, that means pH like 0, or a concentrated strong base, like a pH of 13, 14, are dangerous. But if you have 1 drop of that same acid and you mix it into a swimming pool, now it's harmless. And that means diluted, okay? So if you squirt lemon juice right onto a paper cut, you got a problem, right? It's gonna burn. If you squirt lemon juice into a cup of water, it's dilute, okay? Okay, I wanted to show you this video quickly. This is a superacid, okay? This is hydrochloric or I'll have to check it up real quick. Chlorosulfonic, that's what it is. Chlorosulfonic acid on a tangerine, okay? This is known as a superacid, so this has a pH that's actually in the negative theoretically. It doesn't really have a negative pH, but theoretically it does. And what you're noticing is it's not dissolving or corroding that tangerine, completely invisible. Okay, it doesn't happen like it does in the cartoons where there's a hole in the floor where you dropped the acid. Okay, this is kind of the most aggressive that something could be with a superacid. But this would be known as a concentrated and strong superacid. Okay, so let's practice with that terminology, that strong and weak acid. Okay, I want you to circle 1 word in each of those pairs. So it says HCl is a strong acid. It will partially or completely dissociate, producing many or few of which type of ion? It's a strong or weak electrolyte, all right? Please pause this and try those 2 problems on your own. Okay, this is what I got. So because it's a strong acid, it will completely dissociate. And that means there will be a lot of H plus ions. So the reason I picked H plus is because it's an acid, a strong base, then I would have picked OH. And that means it's a strong electrolyte. It's good at conducting electricity. AlOH3, that's aluminum hydroxide, that's a weak base. So it will only partially dissociate. So there will be a few base ions, hydroxide, which means it will conduct electricity, but it's going to be a weak electrolyte. And the last thing I want to look at with you is this problem, okay? So please read through it, try it on your own, okay? All right, in the illustration below, the light bulb on the left is very bright, okay? The strong current of electrons is possible because of the high concentration of ions in the solution, okay? It's good at conducting electricity because there are a lot of ions. High concentrations of ions are produced by the complete dissociation of strong acids or bases. On the other hand, weak acids and bases do not dissociate completely, so they would produce only a weak current of charges with a dim light, which is not pictured here, okay? The substance on the right hand over here did not turn the light bulb on at all, so it's known as a non-electrolyte. Now again, fill in the blanks, reading this is boring. Please look at this on Canvas, on the button where it says DIY Extra Credit Labs. This YouTube video is genuinely interesting. Okay, it's a good video. There's just a couple questions you have to answer for this extra credit. Thanks so much, y'all.